Yes, hi students. Here I want to discuss about the batteries. You know what is a batteries? The batteries means it is a device which converts the conversions of the chemical energy into electrical energy. Is known as a battery. In the battery consists of a large number of galvanic cells. They are arranged either in a series or parallel to generate the current. Okay. There are two types of a battery. One is a primary battery. Second one is a secondary battery. Primary batteries. Second one is secondary battery. Secondary batteries. There are two types of battery. What's a primary battery? The primary battery means these are the battery which can be here in these types of devices only once chemical reactions takes place. After use of this battery for a long time, this battery get dead and this battery cannot be reused. Okay, but in the case of the secondary battery, these are the devices which can be used for a long time and it can be recharged. Means after use of for a long time, it can be reused. But previous one is a primary battery cannot be reused. So this is the difference between the primary battery and secondary battery. So primary battery, good example is a dry shells. Is an example for this one, dry shell or a mercury shells. Mercury shell is an example for the primary battery. So secondary battery, lead storage battery. Lead storage battery is an example for this one, storage battery. Or nickel cadmium battery. Nickel cadmium battery. It is also example for the secondary battery. So now I want to take about the primary battery. First, only primary batteries I taken here. So first I discuss about the dry shells. Okay, next first I discuss about the dry shell. Dry shell. This is example for the primary battery. Okay. Now it is one more name of this one. It's one more name of this one is Lankin shells. It's also correct here. So now I want to construct how to construct and working of the dry shells. Here dry shell consists of one zinc container. This is a zinc container. Now graphite rod is placed in it. Now it is surrounded by the manganese dioxide. This is surrounded by the MnO2, manganese dioxide, plus carbon powder. Carbon powder. Okay. Now this is actually zinc container. Zinc container. Zinc container. Now the space between that, actually zinc container itself is act as a anode. So this one is act as a cathode. Graphite rod is act as a cathode. The space between the anode and the cathode is filled with the aqueous solution of a ammonium chloride plus small amount of anhydrous zinc chloride. Actually ammonium chloride is used as electrolyte solution or electrolyte. Here anode is zinc content, cathode is graphite rod, electrolyte is ammonium chloride. So what is the reaction at the anode? Actually anode is act as a zinc is act as an anode. Actually first ammonium chloride is dissociated. They form NH4. Ammonium chloride dissociated into NH4 plus Cl minus. Actually Cl minus moves toward the anode. As a result anode zinc container become negative charge electrode. Now zinc high tendency to gives the electron. They form Zn2 plus. This reaction takes place at anode. Next, at the cathode, what is the reactions? At the cathode, reaction is actually first here NH plus 4 moves towards the graphite cathode. As a result, NH4 becomes positive charged. Okay, so now NH4 moves towards the graphite. Now, plus it can gain the electron donated by the anode. They form NH3, ammonia plus hydrogen gas gets liberated. So while balancing the equations here, so here 2, here also 2, here 2, equation gets balanced. Now liberated hydrogen gas further react with the manganese dioxide MnO2. They form Mn2O3 plus H2 is formed. This while balance equation here 2. Now this one we can also written as MnOOH twice. This is also correct composition. Mn2O3 H2. So this is the reaction takes place at a cathode. Now I can, whatever the net reaction, overall reactions, okay, overall reactions or net reaction is, we can add these two equations here. 2 electron get cancelled with the 2 electron. Hydrogen gas cancelled with hydrogen gas. So what is the remaining here? So Zn plus 2NH4 plus 2 MnO2 gives Mn2O3 plus Zn2 plus H2O. Okay. Here Zn2 plus Mn2O3 plus H2O. Okay, this is a reaction takes place here. Okay, plus ammonia plus 2 mole of ammonia. NH3 is formed. This is a reaction takes place at which overall reactions of this dry shells. Okay, next voltage developed is around, in this case, 1.5 volt in this reaction. So voltage developed 1.5 volt, and this is mainly used in the devices like transistor in transistors, okay, or a clock, etc. In these types of devices, this battery dry shell is used here. Okay, and this battery cannot be recharged. That's why this is it cannot be recharged, means it's irreversible cell. It is an irreversible shell, not reversible. It is an irreversible shell, because these types of battery cannot be recharged. That's why this is considered as a irreversible shells. If it's battery charged, means it is a reversible shells. So this is about the which one, dry shells. So then I want to move for the second types of shells, mercury shells. Second one is a mercury shells. Mercury shell. So mercury shell is a very small devices. It is mainly used in the camera or a clock or watches, in watch, etc. Okay, in this case you have to remember what are the anode and cathode used for these cases. So main here anode is used for this one is anode is the zinc amalgam, is used zinc amalgam. Okay, it's used as an anode. Cathode is mercury oxide with a small amount of Mn, with a small amount of carbon powder. Mercury oxide plus carbon powder is used. Carbon powder. Okay, carbon powder is also added. Next, electrolytic solution is potassium hydroxide is used as electrolyte. Now, what is reaction takes place in the mercury shells? So first at anode, the reaction takes place at anode is Zn, zinc amalgam plus OH. It is from the electrolyte. They form zinc. Okay, they form zinc plus H2O. Okay, H2O plus electron is formed. Zinc oxide plus H2O plus electron is formed here. Next, balance the equations here. Here 2, here also 2. Equation gets balanced. Next, anode. Anode is over. Next, cathode. What's the reaction takes place at a cathode? So which is a cathode here? Mercury oxide. Mercury oxide plus H2O. It's formed at anode plus 2 electrons. They form mercury plus OH minus. Then balance the equation. While balance the equations, here 2. Okay, here also 2. Equation balance. So net reaction, I can add the equations. So net reaction is we can here this will be cancelled here. 2H2H cancelled. H2H2 cancel. Zn Hg plus HgO gives ZnO plus Hg. So this is the reaction. Net reaction takes place this one, and voltage developed in this around 1.35 volt is a voltage developed during this reaction, mercury shells. Okay, now next about the secondary battery. What is secondary batteries? Actually this secondary batteries used can be recharged after once chemical reaction is completed. During the recharging, the electrode reaction completely reversed. So good example for the secondary battery is lead storage battery. Lead storage battery is example for this one. Actually, lead storage battery is used in an inverter or automobiles. Actually, in these types of battery, means lead storage battery consists of a large number of galvanic cell or voltaic cells arranged in the series to generate the current. Okay, in each cells, which is the anode and cathode, in each shell, because large number of voltaic cells are there here, or galvanic cells are there, in each shell, anode is the grade of lead packed with the spongy lead or powdered lead, and in cathode is the grade of lead packed with PbO2, lead dioxide. Means here grade of lead actually is a lead packet this way. This is a lead packet. Large number of lead packets are there here. This is a lead packet. So one of packet is act as anode, another packet is act as a cathodes. Okay, large number of these ones are there here. So in case of the anode, it's filled with the lead, powdered lead, spongy powdered lead is filled. In case of the cathode, lead dioxide is filled here. Okay, here lead dioxide is filled. Lead dioxide is filled here. PbO2. So this is act as which one here? Act as a cathode. So these are act as a anode. Okay, this is act as a anode. Act as anode. Okay, this is act as a anode. This is act as a cathodes. So this is because large number of voltaic cells are present here. What is electrolyte solutions here? The electrolyte is 38% by mass, 38% volume by mass, V by W. Okay, the volume by weight, concentrated H2SO4. Okay, H2S, concentrated H2SO4 used as electrolyte. This is used as electrolyte here. Okay, so now what of the reaction takes place at anode and cathodes? So first I take for at anode. At anode, the reaction is first lead dissociated, they form Pb2 plus 2 electron. Next, Pb2 plus combined with the SO4 2 minus. This comes from the electrolyte. They form PbSO4 is formed. Then we can add these two equations here. So Pb2 plus cancelled here. Pb plus SO4 2 minus. they form PbSO4 plus 2 electron is formed. Next, at the anode, what's the reaction? So at the cathode, what's the reactions? The reaction takes place at the cathode. So here lead dioxide, PbO2 plus H plus comes from which one? Acid. Here reduction reaction takes place. They forms Pb2 plus is formed plus H2O. Okay, while balancing equations here, balance the equations. So 2, here 2, here 4H plus, here 2 electron. Equation balanced. Next, once again, Pb2 plus, once again react with the SO4, 2 minus, they form PbSO4. Afterwards, we can add these two equations. So Pb2 plus cancelled here. So we get PbO2 plus 4H plus SO4 2 minus plus 2 electron. They form PbSO4 plus 2H2. This is the reaction takes place at the anode. So cathode. Then what about the overall reactions? So overall reaction is so reaction takes place at anode Pb plus SO4 2 minus, they form PbSO4 plus 2 electrons. Reaction takes place at a cathode PbO2 plus 4H plus SO4 2 minus gives plus 2 electron. They form PbSO4 plus 2H2O. We can add these two equations. Okay, which term is get cancelled here? 2 electron get cancelled here. Remaining term write as it is. What's the net reactions here? Pb plus PbO2 plus See, 4H plus SO4. Actually, 4H plus means I can write here H2SO4. How many mole of H2SO4? 2 H2SO4. They form Pb, 2 PbSO4 plus 2 H2O. Okay, this is the net reaction takes place here. Okay, now this is a reaction takes place at discharging, providing current. Discharging. This is the reaction takes place in charging, recharging. The recharging reverse reaction, discharging this reaction. During the discharging means providing current. Lead sulfate is formed at each electrode. But following the discharging, lead sulfate is decomposed at each electrodes. Okay. And one more point, during this reaction, whatever the concentrated H2SO4 goes on decreases. If density of the H2SO4 comes below 1.2 gram per ml, then battery can be recharged. Okay, when density of the H2SO4 comes below 1.2 gram per ml, then again you can add which one? Battery recharge. After doing the recharging, again sulfuric acid is formed. Then again this can be used here. But here voltage developed, each cell is around 2 volt. And it is a reversible cell. It is reversible, not irreversible, because it is reversible. It can be recharged. Discharging and recharging, both processes are takes place. That's why it is a reversible shells. Okay. Another important secondary battery is nickel cadmium shells. Actually, nickel cadmium shell is a longer life than lead storage battery, and it's very expensive to manufacturing. Its point is it has longer life than lead storage battery, and it is very expensive to manufacturing. It is very costly to manufacture, expensive to manufacturing. Okay. So now what are the electrodes are used here? First, anode. Here anode used in this reaction is is cadmium. Cadmium itself is act as an anode. Cathode is metal grade okay, metal grade containing nickel oxide. Then electrolyte used this reaction. Potassium hydroxide KO is used as a electrolyte used in this reaction. So now what is the reaction takes place at the anode and the cathode? So at the anode, here which is act as anode, cadmiums. So cadmium plus OH, it comes from which one now? Electrolyte solution. They form cadmium oxide plus H2O, okay, plus electron. So we'll balance equation 2. Here also 2 equation gets balanced. At the cathode, reaction is nickel. Actually, nickel oxide is dissolved in a KOH. They form nickel hydroxide, NiOH thrice. Okay, plus electrons, they form NiOH twice plus OH minus. Okay, afterwards we can add these two equations. While adding these two, this equation multiplied by 2. Okay, otherwise I want to cancel 2 electron. 2 electron cancelled here. 2 electron cancelled. 2OH cancel. What's it get here? Cadmium plus NiOH thrice. I can write a reversible symbol here. They form cadmium oxide plus nickel hydroxide plus H2O. So this is about the charging and discharge. This is a discharging process. Discharging means providing the current, and this is a recharging. Okay, discharging, during providing current, this reaction takes place, forward reaction. But during the recharging, reverse reaction, backward reaction gets favored here. Okay, this is about the nickel cadmium battery. So main drawback, it's a very expensive manufacture, but longer life than lead storage battery. Okay, next concept is a fuel cell. What is a fuel cell? Fuel cell is a galvanic shell which converts the energy produced by the combustions of hydrogen, methane or carbon monoxide, etc. into electrical energy. Okay, such devices, electrical energy, such devices is known as a fuel cells. It is actually galvanic cell. The main function which converts the energy produced by the combustion of this fuel into electric energy is known as a fuel cells. So good example for the fuel cell is a hydrogen oxygen fuel cells. Now I want to explain the construction and working of a hydrogen oxygen fuel cells. The hydrogen fuel cell means actually combustion of the hydrogen with the help of excess amount of oxygen. They produce water. That energy converted into electric energy with the help of the fuel cells. So in this fuel cells, there is one compartment tank. For this tank, there are 2 electrodes are immersed here. There are 2 electrodes. One of them is act as an anode, another one is act as a cathode. So this is a graphite rod. Actually, porous graphite rod is used as electrodes here. Okay, this is a porous graphite electrodes. Porous carbon electrodes. Electrode is taken here, and here potassium hydroxide or sodium hydroxide solution is used as electrolytic solutions. This is a potassium hydroxide. It is used as electrolyte during the reactions. So now these 2 electrodes are connected. One of this acts as an anode, another one is act as a cathode. Okay, so and for this electrode, some coating is given, platinum coating or a palladium coating, platinum or a palladium coating is given to the electrode. Okay, so coating is a platinum or a palladium coating is given for the electrode to increase the speed of the reaction. This is the catalyst. Palladium coating or a platinum palladium coating is given to increase the speed of the reactions. Okay, now so now there are two compartments. Now here for one compartment hydrogen gas is passed, another compartment oxygen gas is passed here. The hydrogen gas is a gas passed at anode compartment. This is anode, this is act as a cathode. Hydrogen gas introduced into the anode compartment, oxygen gas passed into the cathode compartment. So now reaction takes place at anode and cathode. So at the anode, what is the reaction takes place here? At the anode, so hydrogen combined with OH minus, it comes from the electrolytic solution. They forms H2O plus electrons. Then you have to balance the equations here. H2. So now here 2. So here also 2, 4 now. So oxygen is a 2, correct. Here also 2 electron. This is the reaction takes place at the anode. At the cathode, what's the reaction? At the cathode, so which one gas passed here? Actually, oxygen gas passed into the cathode compartment. So O2 plus H2O is already formed now, plus electron, they form OH minus. So balance the equations here. Here 2 is equations, here also 2 equation gets balance. Here hydrogen number, hydrogen 2, here also hydrogen 2, but oxygen is a 4 now. That's why here I put here 2, here 4. So here also 4, equation balance. What number of hydrogen? 4, oxygen 2 plus 2, 4, correct. So afterwards net reaction. How to get a net reactions? Net reactions. So net reaction is obtained by adding these two, but first equation you have to multiply it by 2 to cancel the electrons. So 2 electron is 4 electron cancelled with the 4 electrons. Next here 2 into 2, 4 OH cancelled with the 4 OH, correct. So then what is 4 OH is here. So here 4 H2O, here 2 H2 cancelled, here 2 H2O cancel. So what is remaining here? H2O, 2 H2O plus O2. Here this is a cancelled, okay, gives 2 mole of H2O is formed. So this is a net reaction. Conversion of hydrogen with oxygen, they produce energy. That energy converted into electric energy. Such devices is known as a fuel cell. But this fuel, this shell is the important advantages of this shell is it is actually the efficiency of this shell is 70%. This is important. Efficiency of this shell is 70% as compared to thermal plants, thermal power plants. Actually, thermal power plants, there also combustions of fuel are converted into electric energy, but their efficiency is only 40%. But this efficiency is 70%. So efficiency of this is very high as compared to the thermal power plants. Okay. Second one is it is free from the pollution. It did not cause any pollutions, air pollutions or noise pollutions. It is free from the pollution. And one more advantages of this one, it's continuously providing the energy. Okay, these are the main uses of the fuel cells. Okay, next concept is the corrosion. What is a corrosion? When metal exposed to air or atmospheres, they can react with the air and moisture of the atmosphere to form undesirable metal on the surface of the metal. Such a phenomena is known as a corrosion. Okay, so in generally definition, when metal exposed to air, okay, exposed to air, they react with or exposed to atmospheric conditions. Okay, atmospheric condition. atmospheric condition, they react with the air or moisture to form undesirable compound on the surface is known as a corrosions. So good example for the corrosion is rusting of iron. Okay, rusting of iron is example for the corrosions. It is an example, rusting of iron. Now actually corrosion is a electrochemical phenomena or electrochemical process. Corrosion is an electrochemical process. Means it involving both oxidation and reduction reaction. We know that any process become electrochemical when delta G is less than 0, delta E electropotential is must be the greater than 0. This is the conditions. Here corrosion is electrochemical phenomena, means delta G is less than 0 and potentials, okay, electrode potentials, standard electrode potential must be greater than 0. This is a condition for the electrochemical process. So how it is an electrochemical process? I take a rusting of iron as an example. From this one I can explain that rusting of iron is electrochemical process. So in generally when iron piece exposed to air, there are two types of reaction takes place. One oxidation reaction, another one is a reduction reaction. First of all, what is a rust? What is rust formula? Rust formula Fe2O3 dot XH2. This is the rust formula of the rust. Hydrated ferric oxide is known as a rust. This is the formula of the rust. Okay. Now, how it becomes electrochemical process? There are two reaction takes place, but one is oxidation reaction and a reduction reaction. Oxidation reaction takes place at the anode, reduction reaction takes place at the cathode. Actually, when iron piece exposed to air, first iron itself loses the electron. Iron loses the electron. They form Fe2 plus 2 electrons. This process is called a oxidation reaction. Another one is a cathodic reaction, means reduction reaction. Actually, iron loses the electron. This is, suppose we assume that this is iron piece. At any one region, they loses the electron. They forms Fe2 plus and 2 electron. These 2 electron move some other regions where reduction takes place using the moisture and oxygen of the atmospheres. Okay, here means that electron moves, their reduction takes place using moisture and oxygen, means O2 plus H plus. H plus comes from the moisture. Okay, plus electron here. Here, how H plus generated? Actually moisture. Moisture means it may be contain carbon dioxide plus water. They form a carbonic acid, H2CO3 formed. This carbonic acid further dissociated, they form H plus plus HCO3. That's why H plus comes from the moistures. Okay, so now H plus comes from the moisture. So now they forms H2O, water. Final product formed is H2O is formed here. Then you have to balance the equations here. Here 2, here 4 plus, okay, here also 4 electrons. Now what is the net reactions? Overall reaction, net reaction is, we can add these two equations. So which terms? Actually for this equation multiplied by 2 to cancel the electron. If multiply here, 4 electron cancelled the 4 electrons. Okay, then remaining term as it is, no changes. So what is the net reactions here? 2 Fe plus O2 gives 4 H plus gives 2 Fe 2 plus 2 H2O. This is net reaction takes place. So that's why it is considered as electrochemical process. Next, continuations. So what happened next? Actually Fe2 plus is formed once. This Fe2 plus further converted into Fe3 plus by using the moisture and oxygen of the atmosphere. That means Fe2 plus further converted into Fe3 plus by using the moisture and oxygen of the atmospheres. Moistures H2O plus oxygen O2, they converted into Fe3 plus OH minus. Okay, then you have to balance the equations here. Here 2. Okay, here half, equation gets balanced here. Then charges here 2, here 3, 6. Okay, equation gets balanced here. Then, so now here what happens? See, finally we get this. Finally get this one here. Just go through this one. Here 2 is a common. What's remaining here? FeOH3 is remaining here. So otherwise this one I can written as here Fe2O3 dot X means 3H2O. 3H2O. So this is the formula of the rust. What is the rust formula? Fe2O3 dot XH2O. Here X means 3H2O molecules. Hydrated ferric oxide is known as a rust. Okay, so this is the formation of rust on the surface of the iron. This phenomena is known as electrochemical phenomena. Totally, there are two processes involved here: oxidation and a reduction process are involved. This process is known as rusting of a iron, and it is called electrochemical process. The condition is delta H is less than 0. Electropotential must be greater than 0. This is the condition for the electrochemical phenomena. Okay, thank you.